Okay, for this video, we'll be going through the answers in your practical electricity notes. Okay, the practice questions. Okay, so the first one, in which of the following situations will a fuse melt? So we know that a fuse melt when there's excessive current. Okay, when there's excessive current flowing through and it exceeds the fuse rating, the value of the fuse rating. Okay. So let's see which are the conditions that will trigger this. Now, if the earth wire is broken, so typically it will not cause the excess current to flow because the earth wire is connected to the metal casing, right? So it is actually to protect the user in case the metal casing becomes live due to an electrical fault. Okay. But if just the earth wire is broken, it will not cause the fuse to melt. Now, there's a short circuit in the electric circuit. Yes, this will cause the fuse to melt because when there's a short circuit, that means there's excessive current. Okay, now the fuse is fixed alongside the neutral wire instead of the live wire. This will not cause the fuse to melt, but rather it will still mean that if the fuse breaks and it causes if the fuse melts, okay, it will still the appliances will still be connected to the live terminal, which is dangerous, so we don't want that. So it's only number 2, the second scenario, that will cause excessive current to flow, right? So answer is B. Now, next question, the metal case of a vacuum cleaner is earth. There's a fuse that's rated at 5 ampere inside the plug, and under normal circumstances the current flow is 3.3, so it's below the fuse rating. Now the cable is worn out, and then the neutral wire, now for neutral wire it is actually at 0 volts, right? And it touches the metal casing, right? So which of the following statement is correct? The answer is C. The fuse will not melt and there will be no current, and there will be current flowing to earth because if let's say this is the appliances, I just draw a simple one, and this is the metal case. So this is my live, this is my neutral, and the fuse is over here. And because of the freight wire in the neutral wire, right, it touches the metal case. So what will happen to the current? And remember, there is a earth wire. So this is our earth wire. So current flows into the appliances. Then when it comes out here, right, it is actually touching the metal case because of the electrical fault that the neutral wire is frayed. So it touches it, so the current will flow through the metal case and into the earth wire. Okay, but this is just the returning path, right? That means the fuse will not experience an excess current that is more than its fuse rating. All right, so answer is C. Okay, the fuse will not melt, but there will be current flowing to earth because it is the same potential as the neutral wire. Okay, let's look at the next question. The diagram below shows the main part of an electric iron. In which of the following situations will the fuse blow when the switch is closed? So the switch is here, the fuse is here. So this is my live, so X is live, Y is actually neutral. Okay, so answer is A. The insulation at contact point X is worn out. So this is different from the previous question, right? This is where the live wire touches the metal case. So if the live wire touches the metal case becomes live, right? So this will cause current to flow into the metal case and into the earth wire. So at the same time, when the current is flowing into the appliances, there is also current flowing through the metal case into the earth wire. That means there will be excessive current because now it's like a parallel path, right? So this will cause the current to exceed the fuse rating and it will cause the fuse to melt. So answer is A. So if it's at Y, it is a neutral wire, so it doesn't matter. It's a bit like our previous example. Now, heating element is broken, it will not cause the fuse to melt. Okay, it will not cause the fuse to blow because if it's broken, then it will just create an open circuit. Earth wire is removed, also it wouldn't cause the fuse to blow. Okay, 3-pin plug is wrongly wired as shown in the diagram. It's connected to a washing machine with a metal casing. So this is dangerous because look at this. The yellow and green wire is connected to the live wire. Okay. So instead of touching the metal case, it is touching the live wire, which means that so which of the following is correct? When the washing machine is switched on, the user will get an electric shock. Okay, so this part is actually going into the real earth, right? That means the ground of the building. Okay, so by right, this earth wire should be connected here, and so it will flow into the real earth, the ground, if there is current that is flowing in the metal casing. Okay, but now because the metal casing, this side is to the metal case, so do you see that the live and the earth wire are connected here? So the live, so there will also be current that flows into the metal case and makes the metal case live. Okay, so when somebody touches the metal case, it will form the connection. So this is the live wire, yeah. No, this is the appliances. Let me draw it better. Okay, so this is where the earth wire is connected to the metal case. Okay, and this is my live, this is my neutral. So just now, due to the wrong connection, live and earth are touching together. Okay, there's no longer a connection to earth, no more, right? Because by right, this one should go into earth, but it didn't. It's now touching the live. So current will flow through the appliances and back into the neutral. So this thing is working fine. But if somebody touches this, remember this part, it is connected, so the metal case is actually now live. So if somebody now touches it, it touches the earth and touches this, it will form the connection and current will flow into the person. So the person will get an electric shock. Okay. Next, electrical fault occurs in a kettle such that the live wire is in touch with the metal casing. So this is an electrical fault, which is earth. Under normal condition, a current of 6 amperes is delivered to the kettle, which has a plug that contains a 7 ampere fuse. Which of following occurs after the fault kicks in? Okay, the circuit will be switched off. Why? Because now the metal casing is live, and because it is earth, current will flow into earth and into the appliances simultaneously. Therefore, there will be excessive current. So if there's excessive current, the fuse will melt, and therefore the circuit will be switched off. Okay. Now, in the next question, in the 3-pin plug of a heater, a fuse is connected at the live wire but not in the neutral wire. Which of following statement correctly explains the above statement? This is a popular question. Okay, answer is D. Now, if let's say there's an electrical fault, the fuse in the neutral wire blew, the heater could still be at the mains voltage. I think I explained this many times in class, but let's do this again. So this is the appliances. So this is my live, this is my neutral. So this is my fuse. So of course this is a wrong position that the fuse is connected. But if, however, let's say somebody does connect it this way and there's no electrical fault, it is okay. But let's say now there's an electrical fault, okay, and now there is excessive current flowing, the fuse will melt. If the fuse melt, you see that there is no longer a connection to the neutral terminal. But these appliances with the fault over here is still connected to live, which makes it very dangerous. So that is the real reason why the fuse should be in the live and not in the neutral. Okay, in both cases, the appliances will stop working, current will stop flowing. But because of this part whereby the appliances is still connected to live, it makes it dangerous. Okay, last question. Okay, something wrong with the question. Okay, yeah, just look at here. Now the diagram shows how the electric supply cable is connected to an electric kettle. The earth wire is connected to the metal casing. Okay, so this metal case has a proper normal earth wire. Okay, a fault occurs and some loose end of the live wire touch the metal case of the kettle. That means the metal case is now becoming live, right? Which is dangerous. Now the students say the kettle will continue to work. Anyone who touches the metal case of the kettle will get an electric shock. That's the second statement. And third one is the fuse will not melt. So I say again, the kettle will continue to work. Is this true or false? Anyone who touches the metal case of the kettle will get an electric shock. Is this true or false? And lastly, the fuse will not melt. Okay, so based on the information, comment on the three statements. So will the kettle continue to work? Of course not, because when this live wire touches the metal casing, current will flow from the live terminal through the metal casing and into the earth. So that means there's excessive current. So if there's excessive current, the fuse will melt and it will create an open circuit. So the kettle will not continue to work, which means that this statement is false also. The fuse will melt. The fuse will melt. All right. Then anyone who touches the metal casing will get electric shock. This is false as well. So therefore, all three statements are false. Why is it that somebody who touches the metal casing will not get an electric shock? Because there is earth wire. This earth wire is, if it's connected properly, the current will flow through this low resistance wire instead of the person. Okay, but actually it wouldn't wait until the person touches it. The fuse will have already kicked in and creates an open circuit, so the kettle will not be working ready. Okay, so this is the answer for this question, right?